Hello everybody, welcome to SEPAWA 2021. My name is Arnold. I work for the company LUM in Berlin, Germany, and I have the pleasure to talk in brief about the direct and accelerated stability testing of liquid fabric softeners. There will be an introduction, there will be few comments on the patented step technology. I would like to share with you a fabric softener case study, and last but not least to allow you to learn from other experts, as well as to give you a summary and an outlook. Company LUM was founded in the year 1994. 4 years later, the first commercial instrument was sold to a pharmaceutical company. It was a stability analyzer LUMiFuge operating using the same step technology we still use for fabric softeners. In the year 2021, LUM has its own premises. Now we count more than 50 people working for LUM. We have 4 subsidiaries around the world. We are of course certified according to ISO 9001 in the most recent version. And last but not least, the product portfolio of LUM has been extended from a single stability analyzer LUMiFuge to several product lines, laboratory, at-line and in-line instruments to characterize particles, suspensions, emulsions, coatings, composites and materials. The motivation for accelerated stability testing results from the market. Short development cycles are demanded for even products which are stable for a very long time. But often the formulations are complex. They may have many ingredients. There are many possible influences and interactions of internal and external nature during the product lifetime. For example, we may find in the web that the fabric softener works for about 1 year, but we may not wait for 1 year before we may release the next nice fabric softener onto the market. What shall we do? The ISO suggests instrumental methods for accelerated stability testing, and LUM offers you the patented step technology in combination for the physical acceleration to characterize liquid fabric softeners. We can see here a scheme of the setup. We operate at higher gravity. We have the chance to perform multi-sampling. We can investigate up to 12 simultaneous samples. We have the option of the use of different wavelengths. We can run the setup temperature controlled at a constant temperature or even ramp the temperature during the accelerated separation. And the commercial name for that setup is multi-wavelength dispersion analyzer LUMiSizer. In this little video we can see how it is working. We have programmed the instrument by a software on a personal computer. We have filled our 12 softeners into the closed sample cells of the same kind or of different sample type. We put the rotor cap on, we close the lid and the instrument starts to run. The rotor is spinning and during the run we flash from top to bottom simultaneously each sample and get this kind of information, the so-called transmission profiles for each of the 12 samples simultaneously. In our case study we compare one identical formulation which was produced on the production site A and B, which are different. And we can see here in the picture the sample cells with the fabric softener after 17 hours of accelerated separation at 45 Celsius, maximum relative centrifugal acceleration. By naked eye we can see for the production site A, the left part of the picture, that the full scale and the pilot plant A show changes of the sample in the bottom area. Close to the cell bottom we see a phase which appears to be more clear than the area above. Full scale and pilot plant production site B, right part of the picture, appear for the naked eye more or less homogeneous. I would like to acknowledge my colleague Dr. Titus Sobisch for performing the experiments. Here we can see the near-infrared transmission profiles showing the amount of light passing through the sample, y-axis transmission in percent, as a function of the sample cell position, x-axis, and we can see here the sample has changed starting with a red line ending up with a light green line, it has changed starting at the cell bottom. Now we see a clearer phase at the cell bottom after the 17 hours of accelerated separation. This is a so-called creaming process, and it's also typical for oil and water-based emulsions. Once we compare the fingerprints, the transmission profiles for both production sites A on top and B below, we can see for production site A full scale upper left and upper right pilot plant A, there's significant change in the transmission profiles. Lower left, production site B full scale, and lower right, production site B pilot plant nearly do not show significant changes in the transmission profiles. We may quantify this information by using the instability index. The instability index is a dimensionless number between 0 and 1. The higher the instability index, the more unstable the sample, because the sample has changed more. We can see highest value of instability index for production site A full scale, most unstable sample here in red. We can see the most stable sample with the lowest value of the instability index is production site B, the pilot plant. The index has been here calculated after 17 hours at 45 Celsius with a mean relative centrifugal acceleration of 2,100 times. The whole sample range was used for the calculation. Apart from this case study, you are welcome and invited to learn from the real experts. So please go to the LUM website, to publications, and then to the literature link database and search by the keyword softener to get direct access to industrial experts talking about the use of LUM instruments for liquid fabric softeners. And by simply changing the keywords, you may find a huge amount of information on the use of LUM instruments for nearly any kind of application. Please let me summarize this brief presentation. The direct and accelerated stability testing of liquid fabric softeners is done by a direct stability testing of up to 12 samples in their original concentration under identical conditions. We directly physically accelerate by using relative centrifugal acceleration in the range from 6 up to 2,300 times possible. Now, there's, in addition to the constant temperature measurement, also the possibility of a temperature ramping. It allows for a rapid formulation screening. It saves you time and money and storage space because you will significantly reduce the number of formulations for subsequent real-time tests. Last but not least, there are many more opportunities by the same instrument provided. Have a look at this slide here. We have spoken in brief about the accelerated stability testing of samples in their original concentration, but the LUMiSizer is a full particle and droplet sizing instrument. You may obtain information on particle density distributions as well. You may characterize particles of liquid and of solid nature, also according to other properties, Hansen parameters, magnetic properties, adhesion of particles, and last but not least, in the LUMiSizer, there are also filtration experiments enabled by the use of specific filtration cells. Just go to the literature database on the LUM website and perform your own keyword search and get connected to users of the different applications. I would like to thank you for your attention, and we welcome, of course, your questions at any time at info@lum-gmbh.de. It was a pleasure for me. You were listening to Arnold Uhl, Company LUM in Berlin, Germany. Have a nice SEPAWA 2021.